So length can be measured with some error, say error 1. Height can be measured with some error 2. And the question was, if you think about those two errors affecting the error in my computation of the area, which one is affecting the most? Did you give it any thoughts? So what do you think?
The idea that I came up with was that since the height is smaller proportional to the length, any error on the height could produce a larger error when calculating the error.
So you are saying that this error influences the area more than that one?
Assuming that they're approximately the same amount of error.
Oh, yes. So those are relatively small with respect to any actual measurement. Dave, did you have the same thought?
Yeah.
Why?
I was just thinking in terms of proportions also, like the proportion of error to the height, proportion of error 1 to the length. The height is smaller than the actual effect on the area.
Height is smaller, has more effect on the area. Okay. Any opposite? Yes.
The way I would think of it is that the total error would be the two multiplied by each other.
Yes.
And since the length is longer, you might expect that error to be larger, and the larger of the two would multiplied by each other. That effect is even greater. So I would think the error on the length would be more important.
Because when you multiply, the length contributes more to the product. So maybe the error in the length contributes more to the error. So that's another valid thought. Right? So how to think about it? Well, the way to think about it would be to say that we have one variable, length, and another variable, height. And then what I want to compute is a function of those two. And in this case, it's a very simple function. It's x times y. And then I'm really interested in computations that happen very close to some actual values of length and height. And I don't know those values exactly. But I probably have a rough idea of what those values are. So, well, let's say, just to be specific, this length is 200 units. And that height is equal to 100 units. And then, what I'm interested in is behavior of this expression, of this function, close to the value x equals 200, y equals 100. Right, so I'm interested in f. Well, in values of f. At points close to the point 200, 100. So now we are coming slowly to the setup of doing approximations. Right? We have a point of major interest, and the idea now is to replace that relatively complicated function with a linear function. So how would you replace a function x times y with a linear function?
Take the partial derivative.
Take partial derivatives. So what we used to replace with a linear function, with a linear thing, is not a function itself, but something like expression. Right? So what I'm actually interested in is the error the difference between the value at xy, that is close to 200, 100, and the value at that point. So how do we do linearization? Well, we have to take partial derivatives. We have to take partial with respect to x. It is y. And the partial with respect to y, it is x. And what is it that we make? Well, we put them together after evaluating, right? Fx at that point of interest is what? 100, and Fy at that point is 200. And then we use those coefficients. So Fx at that point should be multiplied by x minus 200, and then this number 200 should be multiplied by y minus 100, and what is that? What is it that we are making here? Oh, it's a linear expression. It's a line, but so far there is no equation. But we don't expect equation, we expect approximate equality, right? So this is approximately equal to what?
The area of the rectangle.
You think so? Well, you see, suppose I made no error at all, so that x equals 200 and y equals 100, then the whole value is 0.
Calculate the error.
So that is approximately the error, right? This quantity. It's approximately f of xy minus f of 200, 100. So, can we make a conclusion at this point? Does it help at all? Because I did something, right? And what's the relevance?
It looks like the height is being multiplied by a larger number, so the error contributed by the height.
So this is the error 1, and that is the error 2, right? So the total error in the area is approximately, not exactly, but approximately, equal to 100 times error 1 plus 200 times error 2. And now you should tell me which one is more important.
Height.
The height.